Imagine sending a message into the void, a message that might drift silently for eternity, carrying with it the story of humanity itself. Right now, at this very moment, two small spacecraft are doing exactly that, gliding through a darkness so profound that our sun is nothing more than a distant, dim star. They've been traveling for nearly 50 years, crossing boundaries no human-made object had ever crossed, and soon they will go silent forever. These are Voyager 1 and Voyager 2, and their journey is more than just a space mission. It is the most audacious, most ambitious project our species has ever undertaken. What these probes discovered has changed everything we thought we knew about our solar system and our place in the cosmos. The story begins with a rare cosmic alignment, something that occurs once every 175 years. In the early 1970s, NASA engineers realized that Jupiter, Saturn, Uranus, and Neptune were drifting into a configuration that allowed a single spacecraft to slingshot from one planet to the next, using each planet's gravity to accelerate further into the depths of space. It was a virtually fuel-free ride, like skipping a stone across a cosmic pond. Miss this alignment, and the opportunity wouldn't come again for generations. In the 1970s, NASA had one shot, and they took it. Two identical probes were built, initially named Mariner 11 and Mariner 12, as extensions of the earlier Mariner program that had explored Venus, Mars, and Mercury. But as the mission grew more ambitious, the name no longer fit. Months before launch, in 1977, they were christened Voyager, and their destiny would extend far beyond anything anyone could imagine. Before these machines left Earth, astronomer Carl Sagan proposed an idea that would make the mission timeless. If these probes were traveling farther than anything humankind had ever built, he said, they should carry a piece of us. And so were born the Golden Records, two copper discs plated in gold, attached to each spacecraft, containing 115 images of life on Earth, the sound of wind and rain, the rhythm of a human heartbeat, music from across the globe, and greetings in 55 languages. Somewhere in the darkness of interstellar space, a recording of a human heart is drifting silently, a message in a bottle cast into an ocean so vast we cannot see the other shore. Voyager 2 launched first on August 20th, 1977, followed by Voyager 1 on September 5th. Despite launching second, Voyager 1's faster trajectory allowed it to overtake its twin, reaching its targets ahead of schedule. These two machines, traveling different paths, yet driven by the same mission, were about to redefine what humanity knew about the outer planets. Their first encounter was with Jupiter in January 1979, passing within 216,000 miles of the cloud tops. Voyager 1 sent back the most detailed images ever captured of the gas giant. The colorful bands, the raging Great Red Spot, an enormous storm larger than Earth, were not static textbook illustrations. They were living, churning systems of unimaginable energy. But the most astonishing discovery came from Io, one of Jupiter's moons, active volcanoes, erupting sulfur plumes hundreds of miles into space. Before this, moons were assumed to be inert, cold, lifeless rocks. Io shattered that belief in a single frame. Voyager's discoveries didn't stop there. Europa, another moon of Jupiter, hinted at a hidden ocean beneath its icy surface, a place where life might exist far from the warmth of the Sunday. They revealed Jupiter's faint rings, discovered 3 new moons, and mapped magnetic fields and radiation belts that would forever change our understanding of the giant planet. And then, using Jupiter's gravity as a cosmic slingshot, the Voyagers were propelled towards Saturn, where even greater wonders awaited. Voyager 1 reached Saturn in November 1980, passing within 77,000 miles of the planet's cloud tops. What it found was both breathtaking and terrifying. Saturn's storms were unlike anything on Earth, with winds exceeding 3,000 miles per hour. To put that in perspective, the strongest hurricane ever recorded on Earth barely reached 190 miles per hour. Saturn's storms could strip continents bare. And those iconic rings that look so serene in photographs? Voyager revealed them as a complex, dynamic system of thousands of individual ringlets, waves, gaps, and divisions, sculpted by the gravitational pull of the planet's moons. During the flyby, the spacecraft discovered 3 previously unknown moons, Atlas, Prometheus, and Pandora, each playing a critical role in shaping the ring system. But the mission's most pivotal decision came with Titan, Saturn's largest moon. Scientists had to choose between continuing the grand tour toward Uranus and Neptune or redirecting Voyager 1 toward Titan, whose dense, complex atmosphere had intrigued astronomers since Pioneer 11's flyby. They chose Titan, a decision that meant Voyager 1 would never visit another planet again. Yet it was worth it. The probe detected hydrocarbons beneath Titan's orange haze, hinting at chemical processes reminiscent of early Earth. This single flyby laid the groundwork for the Cassini-Huygens mission decades later, which would land a probe on Titan's surface. The gravitational boost from Titan then flung Voyager 1 out of the plane of the planets, sending it on a course toward the stars, its planetary mission complete. Meanwhile, Voyager 2 continued its journey outward. Using Saturn's gravity, it reached Uranus in 1986, becoming the only spacecraft to visit this icy giant. What it found was a world unlike any other. Uranus spins on its side, its axis tilted nearly 90 degrees, causing each pole to experience decades of sunlight followed by decades of darkness. The atmosphere was unusually calm compared to Jupiter and Saturn, with temperatures plunging to negative 371 degrees Fahrenheit, making it one of the coldest places measured in the solar system. Voyager 2 discovered 11 new moons orbiting Uranus. One in particular, Miranda, stunned scientists with its fractured, chaotic surface, suggesting a violent history of destruction and reassembly under its own gravity. This was a moon that had effectively died and been reborn, a revelation that seemed like pure science fiction but was captured in undeniable images sent back to Earth. Voyager 2's next destination was Neptune, which it reached in 1989, more than 12 years after leaving Earth. Neptune presented a sharp contrast to Uranus. Instead of calm, it was a planet of turbulence, with winds exceeding 1,200 miles per hour and storms of immense scale. The probe discovered 6 new moons, including Triton, Neptune's largest moon, which orbits in the opposite direction of the planet's rotation. This retrograde orbit revealed that Triton was not formed alongside Neptune, but captured from the distant solar system. Voyager 2 also observed geysers of nitrogen ice erupting from Triton's frozen surface, an astonishing display of active geology on a world so cold and remote it seemed impossible. Over 10,000 images were transmitted during this encounter, capturing the majesty and strangeness of a planet previously hidden from human eyes. With Neptune behind it, Voyager 2 completed its planetary journey. No spacecraft before or since has visited all 4 gas giants in our solar system, but the mission was far from over. Both Voyagers were now entering what NASA called the Voyager Interstellar Mission, tasked with exploring what lies beyond the protective bubble of the Sun, the heliosphere. Beyond this boundary lies true interstellar space, a realm of near-complete emptiness, where the faint influence of our Sun is overtaken by the broader galaxy. Before venturing into interstellar space, Voyager 1 performed one final act that would become iconic. At Carl Sagan's suggestion, in 1990, it turned its cameras back toward home and captured a photograph of Earth from more than 6 billion kilometers away. In that image, our entire planet appears as a pale blue dot, smaller than a single pixel, almost lost in a beam of scattered sunlight. That single photograph became one of the most profound ever taken. It revealed that everything humans have built, fought for, and loved all of history has unfolded on this tiny, fragile speck suspended in the vastness of space. After taking the photo, Voyager 1's cameras were permanently shut off to conserve power, ending its ability to see the planets it had once revealed so vividly. Voyager 1 crossed the heliopause in 2012, officially entering interstellar space as the first human-made object to do so. Voyager 2 followed in 2018, making humanity's reach into the galaxy slightly less theoretical and more tangible. Today, Voyager 1 drifts over 15 billion miles from Earth. Even traveling at the speed of light, signals take more than 22 hours to traverse the distance. Every command sent requires nearly 2 days for a response. Over the decades, instruments have been gradually powered down to preserve their diminishing plutonium energy sources. By 2022, Voyager 1 began sending garbled data. Engineers traced the problem to a communication pathway through an inactive computer. After weeks of troubleshooting across billions of miles, they restored proper transmission. Yet time is running out. Estimates suggest contact with Voyager 1 may be lost within this decade, with Voyager 2 potentially lasting until the mid-2030s. After that, these two small machines, the farthest human-made objects ever created, will drift in silence among the stars, bearing their golden records forever. And yet, this silence is not tragic. It is extraordinary. These spacecraft, roughly the size of compact cars, will outlast every building, monument, and artifact humanity has produced. They are silent ambassadors, proof that in a brief cosmic moment, roughly 300,000 years of existence, on one small rock we built machines capable of leaving our solar system, carrying the music, voices, and images of life on Earth. They remind us that our species, despite its limitations and flaws, is capable of profound curiosity and creativity. The Voyager's journey teaches us something deeper about ambition and perspective. In the face of a vast, indifferent universe, we reached out, not expecting an audience, not for profit, but because we needed to try. These machines are the physical embodiment of human curiosity, daring, and intellect. Physics may limit our travel, but it also enables us to harness gravity, build instruments, and understand worlds beyond our own. In sending Voyager into the cosmos, we stretch the reach of human knowledge and imagination further than any monument or library ever could. Once Voyager 1 and Voyager 2 left the planets behind, their mission entered uncharted territory, interstellar space. Beyond the heliosphere, the sun's protective bubble, lies a realm almost entirely invisible to us, a place where charged particles from other stars and the remnants of ancient supernovae drift silently. For the first time, humanity had instruments there, measuring phenomena no one had ever witnessed directly. Voyager 1 crossed the heliopause in 2012, and Voyager 2 followed in 2018. These milestones marked humanity's presence in the galaxy in a tangible way, even if only through radio signals traveling billions of miles. Despite being billions of miles from home, the Voyagers continue to send data, revealing how the interstellar medium interacts with our solar bubble. They detect high-energy cosmic rays, plasma density, and magnetic fields, showing us the invisible forces shaping our cosmic neighborhood. Every measurement, every signal, is a testament to decades of human ingenuity. What's even more remarkable is how we maintain contact. Engineers on Earth send commands and receive signals across distances so vast that light itself takes nearly a full day to travel one way. Each interaction is a delicate dance across the void, requiring precision, patience, and faith that these aging machines will respond. As the Voyagers drift farther, we are reminded of our place in the universe. These probes are tiny, yet they carry the largest ambitions of a species that evolved on one pale rock orbiting an ordinary star. Their golden records, time capsules of our culture, our sounds, our images, will outlast Earth itself, traveling into the galaxy long after our civilization fades. They are a profound statement. We existed, we observed, and we sought to leave a mark. They carry both our curiosity and our humility, a paradox that defines human exploration. Voyager's journey into interstellar space also challenges our perception of distance and time. We live in a world dominated by instant results, yet these spacecraft remind us that exploration can span decades. They were designed in the 1970s, built with technology far simpler than a modern smartphone, yet they remain functional, sending signals back across unimaginable distances. The Voyagers demonstrate that our reach is limited only by patience, persistence, and imagination. And while their discoveries are scientific milestones, they are also profoundly philosophical. The pale blue dot image captured by Voyager 1-inch 1990 remains a symbol of perspective. Earth, once thought vast and endless, is revealed as a fragile speck suspended in the cosmic ocean. Every argument, every achievement, every tragedy in human history has played out on that single pixel of light. Voyager 1 and 2 show us that even in the face of the infinite, small actions matter, and efforts to understand our universe are acts of courage and beauty. Looking ahead, the Voyagers remind us that exploration is not a race, a competition, or a fleeting trend. It is a long, patient process. It is a conversation with the cosmos, a dialogue that stretches across decades and billions of miles. And it is a legacy that will endure long after the final signal fades from Earth's antennas. Now, consider the ticking clock. The Voyagers are powered by nuclear plutonium sources, which naturally decay over time. Instruments and systems have been gradually turned off to conserve energy, one by one, like candles burning down to their final flickers. In 2022, Voyager 1 experienced a critical issue. It began transmitting garbled data. Engineers traced the problem to a computer that had been inactive for decades, rerouting information incorrectly. From billions of miles away, they fixed it, but the window is closing. Voyager 1 may fall silent within this decade, and Voyager 2 could last only until the mid-2030s. After that, the two most distant objects ever built by humankind will drift silently, eternally among the stars, bearing golden records that may never be discovered. This impending silence is not a tragedy, it is an extraordinary achievement. These small machines, each roughly the size of a compact car, will outlast every human-made structure, every artifact, every monument we have ever constructed. They are a testament to our species' unique ability to look beyond immediate survival and express wonder, curiosity, and creativity. Voyager is proof that humanity can act on a scale that dwarfs individual lifetimes, spanning decades and even centuries, all to understand a universe indifferent to our existence. Voyager also challenges us to think about the meaning of legacy. We often measure impact in terms of wealth, monuments, or influence, yet here are two unassuming machines, silently voyaging into the galaxy, carrying the most essential essence of human life, our voice, our music, our image. They are the ultimate ambassadors, a record of what humanity once was, extending far beyond any geopolitical boundary or cultural divide. Their journey redefines what it means to leave a mark. Moreover, Voyager forces us to confront both humility and awe. We are a species that evolved in 300,000 years on a tiny planet, yet in that brief span, we built machines capable of leaving our solar system, traveling into darkness that no human will ever reach. And while the universe is vast, uncaring, and ancient, we are capable of acts of deliberate beauty, curiosity, and understanding. Voyager embodies this paradox: fragile, small, yet audacious, powerful, and enduring. Even as they drift farther into silence, the Voyager's story resonates with inspiration. They teach us patience, the importance of planning for the long term, and the courage to reach beyond what seems possible. The missions demonstrate that exploration is not just about discovery, but about the act of trying itself, the relentless pursuit of knowledge, beauty, and meaning in an indifferent universe. Finally, these missions leave us with a profound perspective on our place in the cosmos. Every human endeavor, every struggle, every triumph, all of it took place on a pale blue dot barely visible from billions of miles away. Voyager reminds us that even the smallest human actions can ripple across space and time, becoming part of a story that outlives us all. And as we anticipate the moment when the signals cease forever, we can marvel not at the silence, but at what was achieved. As we face the approaching silence of Voyager 1 and Voyager 2, it's humbling to reflect on what these small machines represent. They are more than spacecraft. They are monuments to human curiosity, courage, and imagination. For nearly 50 years, they have traveled farther than anything else we've built, pushing past the planets, past the edge of our solar system, and now venturing into the vast unknown of interstellar space. Their journey is a testament to the power of vision, to the idea that even a single species on a tiny planet can reach across unimaginable distances to explore, to learn, and to leave a mark. Every photograph, every data packet, every measurement sent back across billions of miles has expanded our understanding of the cosmos. Jupiter's storms, Io's volcanic eruptions, Europa's hidden ocean, Saturn's intricate rings, Titan's thick atmosphere, Uranus's tilted rotation, Neptune's great dark spot, Triton's geysers, these were revelations no human could witness firsthand. And yet, through the Voyagers, we experience them. These discoveries reshaped not only planetary science, but our perspective on what is possible in the universe. Beyond the science, the Voyagers remind us of something profoundly human: the desire to reach out, to communicate, to be remembered. The golden records they carry are not just time capsules, they are a message of presence, of existence, of hope. Somewhere, perhaps, in the vast emptiness between stars, that message may someday be found. But even if it never is, the act itself, the courage to send a piece of ourselves into the void, is what matters. We didn't do it for recognition, profit, or certainty. We did it because we could, and because curiosity demanded it. As these probes drift silently through the darkness, they leave behind a legacy that no monument, no library, no human achievement could ever match. They are proof that a species capable of immense destruction can also create unparalleled beauty. They are proof that even in a universe indifferent to our existence, we can respond with music, images, science, and imagination. They are proof that the brief flicker of consciousness that is humanity can touch the edge of eternity. Soon, we will lose the final signals. Voyager 1 may go quiet within this decade, Voyager 2 sometime in the 2030s. After that, the most distant objects ever built by humankind will continue drifting through the stars forever, silent witnesses to our curiosity, perseverance, and audacity. But in that silence lies a story more powerful than any words, any monument, any celebration on Earth. It is the story of who we are and what we dared to do when faced with the infinite. And here's the most important part. The Voyagers teach us that trying matters more than succeeding, that the act of exploration itself defines our species. They remind us that in the face of an enormous, indifferent universe, we can choose wonder over despair, creation over destruction, courage over fear. They are a celebration of curiosity, intelligence, and the human spirit. So as you look up at the night sky tonight, remember that somewhere out there, two small machines continue to drift, carrying the essence of us into the unknown. And if this story has inspired you, take a moment to explore, to learn, to marvel at the universe around you. Share this video with someone who loves space, hit that like button, and subscribe to continue exploring the cosmos with us. The story of the Voyagers is far from over. As long as we remember them, their journey continues. Click the next video on your screen to keep the adventure alive.